Hello, in this lesson, we're going to continue to talk about solving more inequalities. And this time we're going to solve simple rational inequalities. What I mean by simple rational inequalities are examples like this. Okay, you see that in your homework. Okay, example number 1, for example, right? We're going to say solve for x. And we got a quotient, right? Rational inequalities, in its complicated form, right? Rational expression, right? So if you guys recall rational expression, you have learned, which is a kind of function, of course, right? It's one polynomial divided by another polynomial. So I trust you guys still remember what is a polynomial, right? And of course, the polynomial in the denominator cannot be 0. Cannot be 0. Okay, so rational expression. So we are not solving very complicated rational expressions. We're solving some simple ones. For example, we may have say x minus 2 over x plus 3, right? And we want this to be positive. We want this to be positive. Okay, so let me increase the fonts a little bit. Okay, so solving rational inequalities. Okay, and how many methods are there? It's pretty comparable to what we did for quadratic. The only difference is in the quadratic case, we can have factor form, right? But in this case, we have quotient form. Okay, I hope this will remind you of principle number 6, right? Principle number 6 says, okay, principle number 6 is about multiplying, right? Positive times positive is equals to positive, right? It's equals to positive. And negative times negative equals to positive. Okay, and the principle number 6, we also address that positive multiply negative is negative, right? And negative times positive is going to be equals to negative, right? And the same principle also applies to division, right? So if we have positive divided by positive, and the quotient is going to be positive. Okay, so when we have negative divided by negative, and we're going to get positive, right? So these are comparative. These are similar situations, okay? So if we have a positive divided by negative, the quotient will be negative, okay? And the next situation would be if we have a negative divided by positive, and of course, you know it, it's going to be negative. In other words, that when we multiply two numbers, if the two numbers are positive or the two numbers are negative, we get a positive. If the two numbers have different signs, and the product is going to be negative. For quotient, it's the same thing. When we divide two numbers of the same sign, the quotient will be positive. When we divide two numbers of opposite sign, and the quotient will be negative. And of course, we never divide by 0. Okay, so we are using the same principle number 6, number 6, okay? So this is going to be the contents of this lesson. Now you can understand why we put these topics together in this week. Okay, they're all very similar. So how do we solve this inequality? And of course, there are multiple methods to solve this, right? The first method, right? We will look at the sign. We look at the sign. Okay. So we look at the sign. Where does x minus 2 change its sign? Where does x plus 3 change its sign, right? If you have learned these methods, you probably remember that we're going to do, we're going to set the denominator equal to 0. We're going to set the numerator equal to 0, right? We set the denominator equal to 0. When we set denominator equal to 0, what do we get? We get, let me put this here, okay? We get x equals to positive 2. Set numerator equal to 0, so x equals to 2. What does it tell us? This tells us that x minus 2 changes sign at 2. In other words, if we look at the sign of x minus 2, which has a domain has a domain of all real numbers, right? X minus 2, x can be any real number. The sign, right? The sign of this quantity, this should look familiar to you, right? So the sign of this quantity, if we plug in x as a number smaller than 2, we're gonna get a negative number. So we get a bunch of negative. At 2 is gonna be 0, right? Larger than 2 is gonna be positive. So this is familiar to you. Okay. So how about x plus 3? Okay, we are also going to set x plus 3 equals to 0. Okay, you don't have to set it obviously, but you can see it, right? You can, if you know it in your mind, that's fine too. So x equals negative 3. So this tells us that x plus 3. Okay, so we know the reason why we do this. Changes sign at where? At x equals to negative 3, right? For similar reason, right? We know that x minus 2 changes sign at x plus 2, x equals to 2. So the reason we set these two equals to 0 is to identify the points where the relevant expression changes sign. It's all okay. Solving inequalities, it's all about sign. We talk about it. It's all about sign. It's all about signs. Okay. So with that understanding, once we know where x plus 3 changes sign, then we can do the same. We can do the sign thing, right? So the sign of x plus 3, right? So at this point, everything seemed to be very similar to what we did about quadratic, right? So we have negative 3 here, negative 3 here. So how does the sign change, right? If you pick a number less than negative 3, you're going to get a negative number. At negative 3 is going to be 0, right? Larger than negative 3, we're going to get a bunch of positive sign. So that's a sign distribution. But what is different from this method from what we did before? We need to have extra care to take care of the denominator because x plus 3 is in the denominator. Therefore, the domain for this entire expression, we have to note, right? The domain is that x cannot be equals to negative 3. Okay, so when we work through these signs, we have to be aware, right? We have to be aware that this quotient has a domain issue. In the quadratic case, the domain is all real numbers, so we have no need to worry about anything, right? So when we consider the sign of this quotient, some extra care has to be taken. Okay, some extra care has to be taken. Okay, so we get sine x minus 2, x plus 3. So when we look at this, when we look at the number line, right, we have the -3 here. And we have the +2 here, right? Now, when we pick a number, okay, when we pick a number which is less than -3, we're doing a negative divided by negative. Negative divide by negative, of course, we get positive. That's easy to do. But at -3, what happens? At a -3, we have a negative number divided by 0. Dividing by 0 is forbidden. Okay, and what do we how do we signal our reader that you understand this? So one thing you can do, you put an infinity sign. Okay, the other one you can do is just put a cross, undefined. Put a cross, undefined. This means undefined. Okay, and between -3 and 2, we are doing negative divide by positive, so those are going to be negative. At 2, we have 0 divided by a positive number, so 0 is in the numerator, therefore that's going to be 0. Larger than 2, positive divide by positive, and that's going to be positive. Okay, so this is the difference, right? Because we're not multiplying, we're dividing. We cannot divide by 0. So when we have a 0 dividing by 0 case, we have to, signal that it's undefined. It's undefined. So you can use a crossing or infinity. Okay. You can even use negative infinity, right? So precisely it should be doing negative infinity because we have a negative number divided by 0, right? So, but anyway, just put a cross to signal the reader that you understand. And now it's time to spell out the solution, right? So what would be the solution we're looking for? We're looking for the product to be larger than 0. I'm sorry, the quotient to be larger than 0. So solution to this inequality are the x values on the number line such that the quotient are positive, right? So these numbers are solutions. Cannot equal to -3, and these numbers are solutions. And how do we describe those numbers, right? Which is going to be x, okay, x less than -3, or x is larger than 2. Okay, x less than -3 or x larger than 2. So those are the solutions. Those are the solutions. Can we use function method? Can we use function method? Of course. It's just the function is going to be a little bit more work. Okay, doing function method is a little bit more work. Okay, so function method. So method 2, yes, you can use function method. Okay, so let's look at this for the same question. Right, we're going to use function method. In the function method, right, you can graph this function. You can graph this function. Okay, if you know that how to identify vertical asymptote, right? Because 3 cannot be, I'm sorry, -3 is not in the domain. So we know that there's a vertical asymptote. There's a vertical asymptote. right? There's a vertical asymptote. That's the vertical asymptote. So that cannot be solution. But knowing that if you have the picture with you and you want the quotient to be positive, right? And you have to show a little bit on this side, okay? You have to show a little bit on this side. So let me just put the view and so maybe this is 6. Does that do? No, you try to make them kind of, you know, separate. You see, there's a crossing. You have to identify these crossing. Okay, so picture-wise, you really have to make some adjustment to so that you have a nice view of it. Okay, so you have a nice view of it. Okay, so you can see there's a crossing here, right? So this entire piece is above x-axis. So this is less than -3. That's positive. On this piece, there's some negative, there's a 0, there's a larger than 0, right? And you just have to see, you have a good view of it, and you need to identify the x-intercept. You need to identify the x-intercept because that x-intercept, okay, so that x-intercept tells you where it crosses, right? So how do you identify that x-intercept, right? Knowing the domain that x cannot be equals to -3, okay, this you have to be really, you know, plodding along analytically. And you also want to identify, so everything's worked out in the domain. So you're going to set this piece equal to 0. And the purpose of doing this is to identify the x-intercept. Okay, since x plus 3 cannot be 0, it's guaranteed. If this is 0, then the numerator must be 0. So x minus 2 must be 0. If x minus 2 is 0, so you get your x equals to 2. So your x-intercept is found. X-intercept is found. Okay, so that x-intercept is 2, 0, right? So you can put that point on the curve, on the picture, and it should be a circle because we want it to be positive. We want it to be positive, right? So maybe I should make it a red circle. A red circle right there, right? So then you can identify, say, hey, we want the quotient to be positive, so this piece is a positive, and this piece is a positive, right? And this piece is a negative, and so your solution becomes obvious, but you still need to identify the x-intercepts. You still need to identify the x-intercepts, okay? So that's the solving this inequality. So now it's time to, with the picture, right? With the picture shown, right? If you don't have a calculator, the graphing can take some time. You can still do it. Why not? Right? You just have to plot points. So comparatively, I think the first method is more straightforward. Okay, the first method is more straightforward. Okay, you can also use table method. Here, I'm not going to repeat that because I have other examples to show you. Okay, other issues, other more important issues to deal with. Okay, can you use a logical method? Yes, you can use a logical method. Can you do the completing square method? No. Okay, completing square method would not apply here, at least not, I don't see it. So a couple methods, all right? So all these ideas you can explore, okay? You can explore. So the solution, okay, so let's give the solution here. The solutions are the same. The solutions are the same. Okay, so the solutions to this inequality are the same, whether you do the function methods, or you do the, you do the sign methods, right? And you can try other different methods too, okay? Go ahead, try it. If you have any questions, feel free to talk to me. Okay, example number 2. Example number 2, okay? Example number 2 that I'm going to choose a question from our homework. Okay, and there's some issues we want to address. Okay, 3 plus x over 3 minus x. This is one of my favorite questions. And I have given tests, I've given these questions on the exams multiple times. Oh, sorry, greater than 1. Okay. To solve this inequality. Okay. I want to show you a case. This case is some people's work. Okay, so this student would do is multiply both sides by 3 minus x. Okay, I'm sure this student actually is fully aware of the domain. Denominator cannot be 0. And the student seemed to be quite aware of it, but this is what he did. He or she did. Okay, I saw this kind of questions, this kind of answers multiple times. I would say many, many times. Multiply 3 minus x on both sides. And then the student will cross out the 3 minus x and have 3 plus x larger than or equals to 3 minus x. Right? And this student is going to move the x to both sides and subtract 3 on both sides. So the student will get 2x greater than or equals to 0. And divide both sides by 2. And x is greater than or equals to 0. And it's done. Okay. So this is the answer and this is the solution I saw many times over. Guess what? It's completely wrong. Okay, completely wrong. I should use a red to mark it. Completely wrong. If this is something you would do, please don't. Please don't. I will explain to you why. What is wrong? Right? What is wrong here? What is wrong here? Well, let me clear this. If this is true, you multiply both sides by 3 minus x, right? Even if you're aware of 3 minus x cannot be 0, you still cannot do this. Okay, you can tell the reader that x cannot equals to 3. Okay, that's great, right? You're aware of the domain. Right? You simply cannot do this step. Why? Because we don't know the sign of 3 minus x. Okay, we don't know the sign of 3 minus x. Why is that important? Right? Remember we talk about that if A is larger than B, right? Then when we multiply A with the number C, okay, versus B multiply with number C at the same time, of course, we know that C has to be not 0, right? C cannot be 0. But we have to separate the two cases. If C is positive, then this direction is still going to be positive. Okay, but if C is negative, what happens if C is negative? If C is negative, this inequality has to change direction. Okay, since we don't know the sign of 3 minus x, do we change direction or do we not change direction? Okay, so this is the fatal step. This step is fatally wrong. Fatally wrong. Okay, so this step is fatally wrong. Okay, so this step is fatally wrong. And the rest is, of course, wrong. Don't do this. Don't do this. Okay, because we don't know the sign of 3 minus x. If it's positive, you don't switch. If it's negative, you have to switch. Do we switch? We don't switch. That's where the fatal mistake happened. Can you discuss cases? Yes. You can discuss when 3 greater the minus x is positive or 3 minus x is negative. And that will be a different method to handle it. Okay, that will be a different method to handle it. I can talk about it if we have time. But you cannot blindly do this. Okay, so please take notes. This is all-time terrible mistake, horrible mistake, extremely bad. If you do this, you get 0 because your answer is not right. Your answer is not right. Okay, I'm going to review the answer to you. Okay, I'm going to review the answer to you. Okay, soon. All right, so without further ado, what will be the right way to do it? Okay, so this is actually a very common mistake. Very common mistake. So this piece is a common, okay, this case. So you shouldn't feel bad if you make this mistake, but don't do it too often. It's a common mistake. I hope that makes you feel better because you may not be alone. You are not alone. You're not alone making this mistake. And don't do it. Don't do it. Okay? All right. Even, well, let's just stop here. Okay? So what can be done? Okay, so let me show you the right way to do it. And of course, there are more than one right way to do it. Okay, so let's get started. Let's get started. The right way to do it, the first thing you do, which is the most straightforward way to do, the first method is to make 0. Make 0 again. Why make 0? Why make 0? Because of principle number 6. Why make 0? Because we want to use principle number 6. So I'm going to bring principle number 6 to tag along with us. Okay, so how do we make 0? Okay, we're going to subtract 1 on both sides. Right, 1 minus 1, so that's going to be 0. And then make a common denominator. Okay, and then simplify. Make a single fraction. So the second step is make a single fraction. So the first step is make single fraction, or you can call it a factor. It's a kind of factor. It's a kind of factoring, okay, factor. So how do you factor? Well, you basically make the same common denominator. You make a common denominator, right? How do you make common denominator out of this situation? Well, 1 is equals to 3 minus x under 3 minus x. Okay, and once we have the common denominator, we're going to use that common denominator, which is 3 minus x. And the top is going to take the numerator, 3 plus x, minus 3 minus x. Be very careful, okay? Be very careful. Attach a parentheses here, okay? I saw people get really messed up if they don't attach the parentheses. Okay, opened up the parentheses, you have 3 plus x minus 3 plus x, minus 3 plus x, sorry. Okay, let me make the fonts even larger. Okay, because we can. So 3 minus x, larger than or equal to 0. And when we simplify the top, we can see 3 and negative 3 make 0. X plus x, that's going to be 2x. And denominator is 3 minus x. So that's at least 0. If you like to simplify to the simplest possible, you may do what I do. Okay, I'm going to multiply both sides by half. Oops, I'm going to multiply both sides by half. Okay, you don't have to. But if you are like me, right, you want to make things really simple as possible, then you do what I do, right? So I multiply by half, and this 2 and this 2 will be reduced. So as a result, because we multiply by a positive number, so we have this 2 is gone, this is gone, this is 0, because 0 times half is 0. So now we get to the simplest case. Can we apply principle number 6 now? The answer is yes. Yes. Okay, so now you know what not to do first. So don't do that. You're gonna miss a lot of points. So in this case, I'm gonna use the sign method. Of course, I'm gonna work with the sign of the numerator, which is x, right? That's pretty straightforward because if x is a positive, x is a positive, right? So x changes sign at where? 0, right? If x is less than 0, x is a negative. If x is 0, it's 0. If x is a positive, then it's a positive, right? So this is the most straightforward. And let's look at sign of 3 minus x. 3 minus x, right? Where does it change sign? 3. Okay, you can set it equal to 0. Really, you can do the setting equal to 0. I didn't do it because this is pretty obvious, right? You can set 3 minus x equals 0, and then x equals 3. So you know where 3 minus x changes sign. You don't have to do anything for x because the sign change is pretty obvious, right? So, but this time, be careful, right? When we pick a number less than 3, say 0. I'm sorry, when we pick a number less than 3, we pick a number less than 3. Say 0, right? 0 is less than 3. 3 minus 0 is positive. So on the left-hand side is actually positive. When we pick a number less than 3, add to 3 is 0. But we have to be aware of the domain, right? Larger than 3 is going to be negative. It's going to be negative. Hello. Okay. There you go. So in the end, when we look at the quotient, right? When we look at the sign of the quotient, when we look at the sign of this quotient, what do we get? Right? Number 9, right? Number 9, there's a point 0, and there's a 0.3. Okay. When we pick a number less than 0, we have negative divided by positive. Negative divided by positive is negative, right? So in this case, we get a negative. At 0, right? When we choose x equal to 0, we have a numerator equal to 0, denominator is positive. So this is going to be 0. If we pick a number between 0 and 3, if we pick a number between 0 and 3, we're doing positive divide by positive. Positive divide by positive is going to be what? Positive. What happened at 3? What happened at 3? 3 is not in the domain, right? In fact, we'll be encountering a positive number divided by 0. So that's undefined. So I'm going to cross it out. Undefined. Larger than 3, when we pick a number larger than 3, right? And we have positive divide by negative. Positive divide by negative, we got negative quotient. Okay, so now what will be the solution? The solutions to what? To this quotient, right? We want this quotient to be what? To be greater than or equal to 0, right? We have simplified, we got that. We want that quotient to be greater than or equal to 0. So where do we get those output? Right, where do we get those output? Where do we get those output? It can be equal to 0, right? So here we get all the positives. Not including 3. Does it include 0? Yes. Yes. So our solution is including 0 larger than 0, right? Including 0 larger than 0, but less than 3. Less than 3. So here's our solution. Our solution is less than 3. Right there. Right there. So that's our solution. You see this question, right? First you understand what's not to do. Please don't do that. Please do not do that. Okay, please do not do that. And what you can do, this is what you can do. Are there other methods? Of course, there are other methods. You can use function methods. Okay, the graphing will be a little bit, it's a little bit work, so I'm not going to teach the function method today. I'm not going to teach a function method today. If you have any questions you want to find out, I'll be happy to help you, because I do have another example in mind to show you. I mentioned the case study method. The case study method can be done, which you're going to separate the case, which is 3 minus x is greater than 0, or 3 minus x smaller than 0. You can do that. But I don't think I'm going to cover that method in this lesson, because I don't want to confuse you. We already have covered so many different methods. Okay, so in this case, just be aware there are other methods. Okay, there are many other methods, but for now, just try to understand these methods I've been repeatedly covered, such as the sign, the function. For quotient, it's just the graphing is a little bit too much. If you don't have a device, then this method is much simpler and much more straightforward. Okay, so make sure you study this, because I'm going to quiz you. Okay, so one more example. Okay, this example is going to be example number 3. Okay, example number 3. This example goes like this. It's, of course, is solve for x. Solve for x. Okay, and the inequality goes like this. So 4 over x is less than or equals to x. Haha, what kind of question is that? Right? And once again, can you multiply both sides by x? The answer is no, because you don't know the sign, right? Yes, x cannot be 0, but you don't know the sign of x. So with the correct way to solve it, don't multiply both sides by x. The correct way to solve it is to make 0. How do you make 0? Just bring x over, okay, and less than equals to 0. So make 0. And the next one is a factor. Okay, so these are the most straightforward way to do it, okay, without confusing you. Okay, so we want to be consistent. Make a common denominator. So this is going to be x under x squared. And then what? We should continue to factor, right? We got the same denominator. So it's a 4 minus x squared. And here's x, and less than or equal to 0. And we're going to keep on factoring. So what do we get on the top? We get 2 minus x times 2 plus x. And the denominator is x. We want it to be less than or equal to 0. We got 3 factors. And what are we looking at? This will be the augmented principle number 6. You don't have 3 factors, right? So you multiply, you have 3 plus, 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 minus, minus, plus, plus, and so on and so forth, right? So we'll be considering those cases. So this time, principle number 6 will be kind of generalized, but it's still about sign. So you can see the sign method, even though it takes time, it's just very visual. So we're going to look at the sign of x. No problem, right? Sign of x, we've done that, right? It's equal to 0. When x is less than 0, so this is going to be minus sign, right? 0, positive sign. Boom. You see, it's very straightforward, right? Now, 2 minus x, right? So you may want to identify the zeros, right? What makes 0? Well, set this piece equal to 0, right? And you're gonna get x equals to x equals to 2 or x equals to -2, right? But this time you kind of have more signs to deal with, right? So you're gonna work on the sign of x, 2 minus x. What's the sign of 2 minus x? Where does it change sign? Well, it changes sign at 2, right? So there's a positive 2, right? And there's a sign 2 plus x, right? So when x is less than 2, say 0 or -5, it's going to be positive sign. At 2 is 0. Larger than 2, negative. So how about the sign of, 2 plus x, right? So what would be the sign? -2, right? -2. Okay. And if x is less than -2, it's going to be negative sign. At -2 is going to be 0, right? Larger than -2 is going to be positive. I hope you understand what I'm talking about. Okay, so let me make the font just a little bit smaller so we can see more. Okay, so these three. And next, we're going to look at the quotient, the sign of the quotient. The sign of this quotient. Okay, what is the sign of this quotient? Let's do the number line. Right, we got a -2 here. We got 0 here. We got +2 here, right? There you go. There you go, right? And let's work on the sign. Principle number 6 and more, right? And for the 0, let's see, yeah, there, it's better, right? So we have 3, 4 number lines, okay? So we have them line up, -2, +2, right? And there's a 0 in the middle, right? There's a 0, right? Okay, if we pick a number less than -2, what are we dealing with? We have a negative times positive times negative, right? 2 negative, 1 positive. So this piece is going to be what? It's going to be positive. At -2, at -2, right? At -2, numerator is 0, right? So that's 0. Number between -2 and 0, between -2 and 0, we have positive times negative. That's going to be negative, right? 1 negative sign, 2 positive sign. At 0, undefined. We cannot divide by 0. Okay, we cannot divide by 0. Between 0 and 2, positive times positive divided by positive, right? Positive times positive divided by positive. So that's going to be what? Positive. Positive. At 2, what happens? We got a 0, right? Larger than 2, positive, negative, positive. So that's going to be a negative. Is that clear? Is that clear? Right? 0 is undefined. 0 is a place is undefined. So once we get the picture of the sign for the quotient, and what do we want the quotient to be? We want the quotient to be less than or equal to 0. So the solutions to this inequality is one to make it less than or equal to 0, right? Equal to 0 count. So less than, right? Less than or equal to 0. So where do we find our intervals? Less than 0 right here, right? Less than equal to 0 right here, right? We don't want the positive. A -2 is, make it equal to 0, and then we have a 2 equal to 0, right? So our solution would be one piece is -2 less than or equals to x, less than equal to 0, cannot include the 0, or the next interval would be x is larger than or equals to 2. So that's our solution. That's our solution. Okay. So for solving simple rational inequalities, you have seen a couple of examples, and I hope that these lessons will help you to understand how to do it right. okay? What not to do, and why not to do that, okay? Why not to do, okay? This is the fatal mistake. So please avoid at all cost, okay? So please avoid at all cost. So the general step is making zero, making factor, okay? Making zero, making factor seem to be something we do for quadratic inequalities too, right? Or equations. So making zero, making factor if possible, otherwise using other means. All right, without further ado, I hope to see you guys another time. Thank you for watching. Until next time.